Welcome to EDU World Space.
Okay, so we're doing chapter 34, problem 83 here. So the cornea of the eye has a radius of curvature of approximately half a centimeter. And it says the aqueous humor behind it has an index of diffraction. I'm going to call this NB 1.35. And it says the thickness of the cornea is small enough that we can neglect it, and the depth of the human eye is around 25 millimeters. Okay, so part A. These are the stuff it gives us first, and part A asks for what would have to be the radius of curvature of the cornea so that it alone would focus the image of a distant mountain on the retina, which is the back of the eye. Okay, so first we know that the image formed is going to be given or follow this equation. Minus NA over R, with NA being air, or 1, and NB 1.35 as was given. So for this first situation with a mountain very far away, meaning S is infinity, and we want to focus it on the retina, which is, we said the depth is 25 millimeters behind the cornea, so the image distance is 25 centimeters. Oh, sorry, 25 millimeters. Let's keep it in centimeters though, so let's do 2.5 centimeters, yeah, which is the same as 25 millimeters. So now that lets us plug in everything here. So the first term is going to be 0 since it has infinity on the bottom. So we're going to be left with 1.35 over 2.5 centimeters equals 1.35 minus 1 over r. Awesome. We rearrange for r, and we find that r is 0.648 centimeters. Cool. So just a little bit bigger than what it was. So let's go on to part B now, though. So part B asks, if the cornea focused the mountain correctly on the retina as described in part A, would it also focus the text from a computer screen on the retina if that screen were 25 centimeters in front of the eye? If not, where would it focus it? Okay, so now we can use the object distance of 25 centimeters and the r of what we found before. And let's go back to our equation here. So we should have 1 over 25 plus 1.35 over 2.5. And this equals, oh, sorry. We don't know the image distance here, so we're going to solve for that. So we're going to do S prime. This equals 1.35 minus 1 over 0.648. Awesome. Let's rearrange. We should have S prime equals 1.93 centimeters. Sorry, that was completely not the right number. So let's go ahead and write that out. So S prime is going to be 1.35 minus 1 over 648 minus 1 over 25 inverted times 1.35. Okay, awesome. So now plug that all in our calculator, and that should come out to being 2.7 centimeters. But the back of the eye is 2.5 centimeters, so this actually forms the image behind the retina. Behind the retina. Cool. Let's add a new page here, and let's go on to part C. So part C, given that the cornea has a radius of curvature of about 5 millimeters, where does it actually focus the mountain? Okay, so now we have our equation. I'll just write it out again. equals NB minus NA over R. So what we're trying to find is S prime. So we have 1 over infinity, so that's 0. Then we have 1.35 over S prime equals 0.35 over 0.5. Cool. So let's just rearrange that. See, S prime is 0.5 over 0.35 times 1.35. And we can easily plug that in our calculator. And this comes out to being 1.93 centimeters. So that means it's in front of the retina, since the retina was 2.5 centimeters back. So this image is in front of the retina. Awesome.